Today we will discuss some inverse trigonometric function problems. Number 1. You are given y is equal to tan inverse of 1 plus x divided by 1 minus x. How to solve it? You can solve it in two different ways. You can substitute with put x equal to tan theta, y tan theta. Now we will apply the formula tan a plus b equals to tan a plus tan b divided by 1 minus tan a into tan b. Now if I put x equal tan theta, it becomes y is equal to tan inverse of 1. What is 1? 1 means tan of pi by 4. X equal to tan theta divided by 1 minus tan pi by 4 into tan theta. This is tan inverse tan A plus tan B divided by 1 minus tan B. This is tan A plus B. So pi by 4 plus theta. Now this is tan inverse. This is tan. Tan inverse and tan gets cancelled, and we get pi by 4 plus theta. Now what is theta? We have already put tan theta is equal to x. That means for the angle theta, the value of tan is x. That means theta is equal to tan inverse x. Tan inverse x. This is pi by 4 plus tan inverse x. This is tan inverse of x. Now this is y. If you find dy by dx, that is if you differentiate respect to x, for pi by 4 it is 0, and for tan inverse of x formula is 1 by 1 plus x square. That is answer is 1 by 1 plus x square. This is your basic process. Now we can change the method. Alternative. Now y is equal to tan inverse of 1 plus x divided by 1 minus x. Now if we apply the composite function method, there are two functions. At first it is tan inverse of x, then this is not x, this is a function of u by v form, algebraic function. Now if we differentiate dy by dx with respect to x, then for tan inverse of x, this is 1 by 1 plus x square. Then we'll differentiate the function inside this, that is derivative of 1 plus x by 1 minus x. If you take the LCM, this is 1 minus x whole square, 1 minus x whole square, 1 plus x whole square. Now u by v form, u by v, v square v into derivative of u minus u into derivative of v. Same cancelled. Now what is this? A minus b whole square plus a plus b whole square. So your formula is twice a square 1 square plus b square. You see, this is 1 minus x multiplied to, for derivative of 1 it is 0, for x it is 1. Again 1 plus x multiplied to, for 1 it is 0 and for x it is minus 1. Why minus 1? Before x it is minus sign. Now if you see, this is 2 times 1 plus x square. This is 1 minus x, minus minus plus, this is 1 plus x cancelled. This is 2 and 2 cancelled. Answer is 1 by 1 plus x square. See, both the method gives you similar answer. This is a very good question. Now number 2, differentiate y is equal to tan inverse of sec x plus tan x. Differentiate with respect to x. Now you can apply composite function method, or you can use the formula of class 11's trigonometry. dy by dx, differentiating respect to x. So for tan inverse of x, assume this as x. It is 1 by 1 plus x square sec x plus tan x whole square multiplied to derivative of sec x plus tan x. This is composite function method. 1 by 1 plus, this is a plus b whole square. This is sec square x twice sec x into tan x plus tan square x. For sec x, derivative is sec x tan x. For tan x, it is sec square x. This is sec x tan x plus x square x. You can take sec common. Take sec x common. This is tan x plus sec x. Now in the denominator, what is 1 plus tan square x? This is sec square x. This is again sec square x. So 1 plus tan square is sec square. That means twice sec square x plus twice sec x tan x. If you take 2 sec square, 2 sec x tan x, if you take 2 sec x common, it will be twice sec x into sec x plus tan x. In the numerator, it is sec x multiplied by tan x plus sec x. That is cancelled. Answer is half. Answer is half. Now we can solve this question with another method, alternative. We are given y is equal to tan inverse of sec x plus tan x. From class 11 we can write, we know that sec x plus tan x can be expressed as tan of pi by 4 plus x by 2. Actually the basic formula is sec theta plus or minus tan theta is equal to tan pi by 4 plus or minus theta by 2. This question was there in class book of mathematics. If we apply this result, your y will be tan inverse of tan of pi by 4 plus x by 2. Tan and tan inverse gets cancelled. This is pi by 4 plus x by 2. Now this y reduces to a linear form. If you differentiate y respect to x, you will get dy by dx. For pi by 4 it is 0. X by 2, half is a constant multiplied. For x the derivative is 1. The answer is half. Similar answer. Now we'll solve another question, almost same. Number 3. You are given y is equal to sine inverse of 2x x multiplied by 1 minus x square. Sine inverse of 2x x multiplied by root over of 1 minus x square. Now if I substitute x equal to sine theta, then your y becomes sine inverse of 2i sine theta. This is square root of 1 minus sine square theta. As you know, what is 1 minus sine square theta? This is cos square theta. After square root it becomes 2 sine theta into cos theta. From class 11 we know 2i sine a cos a is equal to sine 2i a. This is sine 2i theta. Sine and sine inverse gets cancelled. This is 2i theta. Now you can see what is sine theta. Sine theta is equal to x. That is, this the value of the sine of the angle theta is equal to x. You can write theta is equal to sine inverse of x. This is called inverse function. In sine function we put in any angle in radian, we get the corresponding value. Now in inverse function we put that value and we get the corresponding angle. This is twice theta. This is twice theta. Theta is equal to sine inverse of x. As I already discussed in my last videos, the derivative of sine inverse x is 1 by square root of root over 1 minus x square. This is dy by dx is equal to 2 is a constant. For sine inverse of x, derivative is 1 by square root of 1 minus x square. This is your solution. Now number 4. I am showing you how to solve questions involving inverse function. Number 4. You are given y is equal to tan inverse of thrice x minus x cube 1 minus 3x square. How to differentiate these functions? Now put x equal to tan theta. We know tan thrice a is equivalent to 3 tan a minus 10 cube a divided by 1 minus 3 tan square a. Now your y becomes tan inverse of 3 tan theta minus tan cube theta 1 minus 3 tan square theta, that is tan inverse of tan 3 theta. Tan inverse and tan gets cancelled. This is thrice theta. As you know, like the last question, theta is equal to tan inverse of x. You can put 3 times tan inverse of x. Now if you differentiate this dy by dx, 3 is a constant. For tan inverse of x, derivative is 1 by 1 plus x square. This is number 4. Now number 5. Y is equal to cos inverse of 1 minus x square by 1 plus x square. Put x equal to tan theta again. Why this? As you know, 1 minus tan square a divided by 1 plus tan square a is equal to cos twice a. Your y becomes cos inverse of 1 minus tan square theta divided by 1 plus tan square theta. Now use the formula of class 11's trigonometry. This is cos twice theta. Cos and cos inverse gets cancelled. This is twice theta. Again your theta will be 2 times tan inverse of x. Now differentiate. This is y. dy by dx is equal to twice of 1 by 1 plus x square. 1 by 1 plus x square. These are basic problems. Let's solve a little bit difficult one. Now we'll go number 6. Now we will solve a difficult problem. Tan inverse of cos x divided by 1 plus sin x. This is a good question. You can apply 2 methods again. You can apply the basic method, or you can apply the concept of trigonometry. Now I can write this cos inverse cos x as cos square x by 2 minus sin square x by 2. Why this? Because this is a formula of cos twice a. Cos square a minus sin square a is equal to cos twice a. And what is your sin x? Is equal to twice sin x by 2 into cos x by 2. This is called submultiple form. tan inverse. This is cos x by 2 plus sin x by 2 multiplied to cos x by 2 minus sin x by 2. A square minus b square is equal to a plus b into a minus b. Now if you see, what is 1? 1 means sin square theta plus cos square theta. You can write cos x by 2 plus sin x by 2 here. A plus b whole square. Cos square x by 2 plus sin square x by 2. This is 1 plus twice ab. Tan inverse a plus b whole square, a plus b gets cancelled. You are left with cos x by 2 minus sin x by 2 divided by cos x by 2 plus sin x by 2. Tan inverse of, if you divide by cos, you will get in the numerator 1 sin by cos tan x by 2, again cos 1 sin by cos tan x by 2. Tan inverse of, we can write this as tan pi by 4 minus x by 2. If you ask yourself, you will get the result. This is tan a minus b, tan a minus tan b divided by 1 plus tan a into tan b. Because tan pi by 4 is equal to 1, this is 1. Tan inverse and tan gets cancelled. This is pi by 4 minus x by 2. This is pi by 4 minus x by 2. This is your y. If we differentiate respect to x, for pi by 4 it is 0, half is a constant, for x it is 1. Minus sign, answer is minus half. This is quite a good question. Let's solve another question. Number 7. This number 7. Y is equal to sin inverse of thrice x minus 4x cube. What is dy by dx? That is derivative of y respect to x. Now you can put x equal to tan theta. Sorry, mistake. X equal to sin theta. Your y will become sin inverse of 3 sin theta minus 4 sin cube theta. Sin inverse 3 sin a minus 4 sin cube a is equal to sin thrice theta. Sin inverse gets cancelled. This is thrice theta. Again you can write 3 theta is equal to, from the substitution method, theta is equal to sin inverse of x. Sin inverse of x, that is dy by dx is equal to 3 times. You can now differentiate this with respect to x. 3 into root over of 1 minus x square. Now Let's move towards another question. Number 8. This is a difficult problem for beginners. This is difficult, but we'll solve it with a simple method. Y is equal to sec of tan inverse of x. Sec of tan inverse of x. What is sec theta? We know sec theta is equal to square root of 1 plus tan square theta. Similarly, we will apply this here. You can write y is equal to square root of 1 plus tan theta. Your theta is tan inverse of x. Then whole square. It becomes 1 tan inverse cancel x square. Now this is function of x, algebraic function. Differentiate dy by dx. Initially we can assume this as a square root of x. If you differentiate square root of x, answer is 1 by 2 root over of x. Remember these steps. Whenever you differentiate a root over function, you get 1 by 2 root over of x. Similarly, for root over of x, it is 1 by 2 root over of x, but it is not x. This is 1 plus x square. Then with the help of composite function, we will differentiate the function inside the root over. This is 1 by 2 into root over of 1 plus x square. For 1 it is 0, for x square it is twice x. Now 2 and 2 cancelled, answer is x into square root of 1 plus x square. Now if we apply second method, y is equal to sec of tan inverse of x, then you can solve it this in a different way. Put x equal to tan theta. That means tan inverse of x is equal to theta. From class 11's approach, what is theta? An angle. This is hypotenuse, this is perpendicular, this is base. What is tan theta? Perpendicular by base. This is x, this is 1. Now you can apply tan theta is equal to perpendicular by base. What is the hypotenuse? 1 plus x square. Perpendicular square plus base square. Therefore, we can write sec theta is equal to hypotenuse by base, root over of 1 plus x square by 1. Therefore, your y becomes, this is theta. So y is equal to sec theta. Y is equal to sec theta. So sec theta is equal to square root of 1 plus x square. Same result. Now dy by dx equals again 1 by 2 root over of x. For 1 it is 0, for x square it is twice x. 2 cancelled, x by root over of 1 plus x square. This is derivative of inverse function with trigonometric substitution. I will get back to you with different problems of other chapters.